All right, internet's fixed. Um, and things look good. Go. Just saw that Michael was having some problems with WebStorm and signals in templates. Have to watch out for that today. But welcome to the stream. It's a beautiful Sunday. This week, well, last week we had some problems. My favorite extension, defined for HTML CSS, yes, just went away. Built-in switchers. This depresses. Oh no. They got rid of one of your favorite extensions. That sucks, man. Which extension was it? But anyway, last Sunday, and if you guys tuned in for the half hour where I tried to make the stream work, it was painful. I went back and was watching the replay, and it would just pause and stutter, and it was horrible and painful. They had to come out and um, they switched out my modem um, for my internet, and then they also did some work out on the street with the junction that comes into my house. So I'm looking today, and my bit rate looks good. It's where it should be. I'm not dropping frames. It says I'm streaming at 30 FPS. Um, oh, it got 1984. Nice. Um, that's an old reference, man. Um, anyway, so internet looks good. And then during the week, just had various things come up. Thursday was one of my daughter's birthdays. And then um, on Tuesday, I don't even remember what came up Tuesday. I need to be better at keeping track of that. Um, I didn't even get to play much games this week. So it was a crazy busy week. This week, things look good. Next week is Thanksgiving, so in the U.S. So a week from Thursday, I won't be streaming on Thursday. Um, I'll be celebrating with my family. Um, Looking forward to that. We just got a turkey that I'm planning on using our smoker for. Um, that that will be good. Really looking forward to that. Really like smoked turkey. Anyways, um, it has been a while, so I'm trying to remind myself where we were. If you saw anything going on before the stream, um, I updated a whole bunch of libraries. Things look good. Angular 19 should be coming soon. Version 19 Thanksgiving feature you are thankful for. Oh man, I actually wouldn't mind streaming, but I don't know that it would go well with my family. So um, version 19, oh, there's some amazing stuff coming that I um, can't wait to play with. I really would have liked to have streamed the early release, but things have just been crazy. I didn't get to it. So as soon as it drops, we'll explore some of the new features. Um, yeah, I turned on a little ding every time I get a message, um, and so that's been helpful. I'm hoping. Uh, yeah, Linked Signal did make it to dev preview, and that is one that I definitely want to. I want to take a look at um, and make sure that I understand it well. So anyway, let's get back into it and look at what we are doing right now. So we've been basically moving stuff from our old store into this new store, right? Um, and currently, we're looking at whether we've got errors in our grid. And we copied this over, and then we've got this analyze errors function. Um, and Then we update every cell to tell it if it's valid after analyzing for errors. So it would be good to figure out what analyze errors does. Interesting. So we run through everything and just check them for errors. And this is interesting because we check rows, columns, and regions for errors all at the same time. If this was costly, this would be an interesting place to explore a web worker. And I may have said this in the past. Um, this is a fascinating little function here, and we can take this straight across. Um, if we go take a look at Excalidraw, um, so if we look at this like this is the Sudoku game itself, right? Um, we've taken a look at how we've numbered the regions from 0, 1, 2, 3, 4, 5, 6, 7, 8, right? And this basic, well, this is turning, yeah, this is turning the regions into a one-dimensional array from a two-dimensional array. Um, but we can also take a look at this like rows. Um, so, we've got, when we're going through this, we're actually going through every row and every column and every region with each step. So we only need to do 9 steps and it checks the entire grid for errors. That's not bad. Wait, we use the error analyzer. Check region for errors. Get column to analyze. Row, column. What? Well, let's take a look at this. I think we can take all of this and just move it over and then take a look at what we want to do. Um, let's just grab all of this code right now. And then we will take get region to analyze. I think we can take all of this and just move it over into our store right now. And then from there, we can take a look at what we want to do with it. Some of this stuff I want to move into the actual store itself. So like analyze errors, I think we can move this into the store. So let's do that. Muscle memory. Keep hitting weird things because of my muscle memory. So here, we can probably move this function into here. We can just an underscore here to analyze errors. We don't need the grid anymore because we'll get that. It will return an array of booleans, well, a nested array of booleans, two-dimensional array of booleans. So we set up this array. That's our errors, and it's basically a 9-dimensional array. So it's an array that we set up each dimension as an array. So that's really just shorthand for that, right? So this is just shorthand for this, but it potentially allows us to change the length. I don't know why we would. And here we can say that grid is the state grid, and then we pass in the errors. And we don't want that. Instead, we want a comma on it. So that all looks good. So we immediately set the state to false. Then we can just say this, or no, not this, state. Check. Call it analyze error. So we call analyze errors, and that returns an array of the old store. Where did that go? Solve one cell, reset grid, cell value changed. Because I think, well, we just looked at it. There was yeah, this check grid for error. So we call analyze errors on the grid, and then we update the cell valid errors. So we probably need this too. And this is just us patching the existing store, where we just go through every row in the grid and every column in the grid. And then we look at the errors array at the same spot. Which is easy to do. So we can take this also, and actually I don't want any of that. Really, we can just take this part right here. Just the for loop is all we want. And we can just add that up here. It is 8 errors. Update cell valid. Cell valid. I like that better. Update cell valid. And update cell valid takes in errors. Is that? Boom. And inside of here, we can just say const grid state grid. Fix that up, and then after the for loop, we just patch state grid. And that should do it. That should set up our grid. So after calling update cell valid, we're not calling update has error. Does update cell valid? Oh, it sets the has error. No, just on that cell. Oh, no, it does. It calls it right here. That's fine. That'll work for now. I'm trying to think about, how would we optimize? But we're gonna say let has error false, that has error to true, and we can also patch has error. We're patching the state once. This works just fine. We're going through there anyway. I'm trying to think of is there a way that we don't do this check every time? But I don't know that it matters. It's only 81 checks, right? Now we can just say state, update cell value. We go. So why are we using row and column here? I'm also not using grid anymore. Why was I using? Wants to scale the rows exponentially, think of the performance. Exactly. And this has been something that I've got a paper that I want to write. But you're not wrong, Michael. And there's a paper I've been taking notes for that I'm going to write for NG Champions here pretty soon. And the premise of the paper is using injection tokens like a pro. Um, what do we do in that case that you're talking about, right, Michael? A lot of times people look at like if statements and things like that, and they're like, "Oh, we got to get rid of these," and things like that. If statements aren't bad um, when you're dealing with small amounts, right? There's something that everybody's learned from CS 101, high school coding, the first time you pick things up, right? Is NG Champions taking articles again? Um, I saw in the chat that people are starting to write articles again. I think everybody got busy and stopped writing. And if NG Champions isn't doing articles anymore, I don't know. It's been a while since I've been in the chat, to be honest. Um, but if they aren't taking articles again, I'll just publish it myself and put it out on Twitter. But the premise is that a lot of people will tell you to avoid if statements. If statements aren't bad, right? Like writing for loops. So this for loop is nested, right? And people are going to be like, oh no, ON squared, whatever, right? And yeah, absolutely, probably. Um, it's guaranteed to go through the worst case scenario every time, right? But in here, n is just 9, right? So this is 81. If you were to unroll this by hand, it would just be 81, 81 checks. Big deal, right? 81 checks for a computer is nothing. Get out to, 20 and now it's 400. Now it's getting painful if you were to try to unroll this loop by hand. And that's like one of the things that you can do to allow a processor to optimize instructions or things like that is to unroll loops, right? And some of the compilers, when they do that, will look at loops and go, well, this is a small loop. The processor can take advantage of running some of these instructions out of order. Let's unroll this loop in the code, right? And so it'll write out every case in the code, and people will often be like, oh, this could be written better as a loop. It may perform better if you don't make it a loop, right? And the compiler may optimize away the loop, but that's not; those are never arguments for why you should or shouldn't do something. Better arguments are: is it easier for people to read? Things like that, right? Like this if statement. This if statement runs 81 times. Um, that's 81 extra instructions we're running, and then potentially trying to set a value 81 times. I could optimize this a little bit better by saying, if not, graph.has error, right? So now, as soon as this is set, then we only hit this first condition, and we don't go into an array search. And there's a small optimization there, right? And maybe I'll bring that one over. Because I don't disagree with that one, right? If I just say if not has error, and that, then we'll set it to true, right? There's a reason why I'm doing this and I'm not doing like one thing I could do is I could just say, hey, has error equals not errors row and column, right? And I don't want triple equals there. I'm setting it, right? So I could do this. It's interesting that it's highlighted this. What is it highlighting that? Add braces to arrow function. What is this? Can be simplified to errors row call. Oh, yeah, it doesn't like the not on it, right? But that would set it to undefined instead of Boolean. which has errors. Oh, can be Boolean or undefined. Why would it? Is that really true? xState has error is declared as Boolean. Oh, really? There might be. I mean, so you're saying um, do that. That's interesting. Because this is basically using the Boolean constructor. Um, I'm curious about this. So if we just grab a console here, and let's just say I do Boolean of that is true. If I do not of that, it's true. If I do Boolean of that, it's true. If I do not of that, it's true. And this may be hard to see. There we go. So basically, I'm just comparing Boolean, right? So Boolean of null is false. Boolean undefined is false. So, and not null, boom, not undefined, boom. That's interesting. I actually like that better. Because it makes the intention more clear. Is you know why they said that? I need to go ask who says it and figure out why. But I think I'm gonna have to agree. Oh, Doug. I like Doug. Um, yeah, makes a lot of sense. Um, I I think this is more. Um, it's easier to understand Boolean of an empty array than it is to understand not of an empty array, right? It's doing the same coercion, um, but using Boolean is a lot easier to understand than not coercion. Um, I'll bet this gets minified to the same thing as not. So um, I don't even think you're going to pay the price there. Um, that's a good call. Um, and yeah, Doug, like all of the people that you know, I've met on the Angular team, um, I will definitely say are often smarter than I am. Um, so what I'm trying to understand is um, why I thought I needed this row and column. I don't know why I thought I needed it. Because this is only for the errors, right? So we're looking at the errors here. So oh, look at that. We've even got update game has error. So then we're analyzing the errors, updating the valid cells. We're checking the grid for errors. We're updating if we have errors. That's an interesting icon. I don't know why I was adding that. I'm gonna take it out until I realize why. I'll probably realize why and kick myself here in a bit. But um, one other thing I want to do here is turn all of these consts into functions. And even though I say functions, don't type functions. Get region to analyze. Let's take a look at these functions. So check row for errors. Is a void function that uses mark cells with errors. I think this is misnamed because we aren't marking any cells, and the reason I know we're not marking any cells is up here we analyze the errors, right? We check the row for errors, but once we've got the errors, then we call update cell valid with the errors. Interesting. There is a post about array.from instead of dot 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 list. Ooh, is that from Doug? That's interesting. So instead of using the spread operator, instead of well, here, man, you sniped me. Good job. And let's see. What am I thinking of? My brain just went blank, but it's looking for mutative. That's the library I'm looking for. Mutative JS. So this is the mutative library, and they've updated their site quite a bit. We go take a look. Mutative is a way to create objects that can't be mutated, which is really good to do with Redux, right? But one of the things that's interesting about mutative is that it has high performance. And if we take a look at the performance, right, it talks about mutative versus typical reducer performance. And so typically people will write reducers like this where they'll have state and then they'll spread the base state and then they'll have some keys and they'll spread things like that, right? Mutative allows you to just step into a draft object. And notice that, what Michael is talking about is early on, the scale doesn't really matter. But once we start getting out to, like 95,000 iterations, the gap really starts to widen in the number of seconds it takes for this test to run. Um, and again, arrays, the same thing, right? Talking about using spread. Okay, let me take a look at LinkedIn. There we go. Copy. Bring that here. Oh no. Let me do it this way. So I need to get better about my social media stuff too. Mastodon's probably a good place to be. Um, so yeah, people will do this, and they'll map an array node. Oh, it's self-documenting, easy to look up. Yeah, concatenation. Okay, very interesting post. But you sniped me because there's an interesting most Angular people are going to Blue Sky. Yeah, they are. And I need to be there too. I've just been lazy about it. But notice again, arrays, right? So right off the bat, they're talking about doing this state where you're spreading an array is 6 times slower than mutative. And even using like a map is 2.5 times slower. And so the spread operator, like how you use your spread operator, can make yourselves much slower than than understanding stuff. And notice the interesting graph here. The way arrays are optimized, they're kind of these plateaus, right? Where things don't change a lot, and then it suddenly jumps, and then it suddenly right. Um, it's an interesting way that arrays are optimized in the V8 engine. Um, and you see like these crazy, like this is handwritten reducer code. Like people write this code all the time. I see this code all the time, and it's slower than mutative. And oh, there used to be a discussion on this page about why. And it actually has to do with the fact that some of the stuff that you do with the spread operator is O of n squared. So like spreading objects actually winds up being O of n squared. Um, yeah, they did a whole bunch of different tests, um, and the code the code is very. I wonder where that went. Maybe they had to take it out because it wasn't always true. Um, and but basically using the spread operator can actually slow down your code. Um, but for some reason the link doesn't work right. Doug said, consider, yeah, it's the intent. The intent is, and quite often the intent is far, and that's what he's saying here with the, preferring array.from. It it makes it easier to read, and the intent is much more, um, just it definitely winds up being much future maintenance becomes easier if you make your intent more clear. Um, so I agree with that. So we'll start trying to do some of that stuff. Anyway, um, mark cells with errors. So we're checking row for errors, but this is not actually marking the cells with errors. This is getting the cells with errors. So let's rename that. We'll call it find cells with errors. And we're using an error analyzer, and the error analyzer, we look, really it's going to mark that as a duplicate code. That's hilarious. But our error analyzers are analyzers that we're adding. So if we go find this error analyzer, I think we just imported it. Yeah, we're just importing it here at the top, and then we're using that error analyzer. The point was that we eventually wanted to swap error analyzers, and I got distracted from what I was saying earlier about my article about using injection tokens like a pro. But one of the things that we can do to make our Angular code use fewer if statements, and I'm not saying you should use fewer if statements if you don't feel like it. Definitely don't do that. But if you do feel like it, one of the things you can do is use injection tokens to inject different concrete versions of your class. And that essentially turns your Angular application into a state machine, where depending on what's injected, your class or your application could behave differently. So one way to take a look at this is, say you have a button on a page, or you have a grid, like if we go back and we think about like the Angular dynos thing that we did a while, right, where we have the dinosaur grid, and then we have a button to add new dinos, but we also have a button to edit the dinosaur. If you click the edit button, what we could do is at that point, we could set the injector for the store that's used in the next part to use our edit injector. And then we could use that edit injector for editing. And so when people save, we take out all the checks for if this is a new dinosaur. We don't run any of the code that's ever run for new dinosaurs, right? It is just the concrete implementation of the store for editing that dinosaur. If we click the new button, then we can set up our injector to be the store for a new dinosaur. And in that case, the next component when it shows up asks for that in that store through the injector through its interface, and it gets the new injector. So it knows that it needs to call different things on the back end. It maybe needs to go out to Chat GPT like we were using to get to get a description of the dinosaur and just all of things like that, you can write those in. And so then you have state machines so that you're never running those checks for if this is a new one, then do this. If it's an edit, then do this, right? Um, and using injection tokens to make your application run like a state machine is an interesting idea. There's another idea, and this one's a little bit crazy, but if we wanted to do like function, we'll call it decorated component, right? And in our decorated component, we'll just have, show, what should we do? We'll call it, I don't know, show user, right? This can be a Boolean, right? So what if inside of here, we just had at component, boom, or no, let's do this. We can do this. Let's just do our selector. We'll make it a string, right? And so inside of our component, we can say, hey, we've got this selector. And then we've got this template. Wow, it's writing ng4. This is horrible. But whatever. For now, we're just going to do this. We're just going to do this. And that's good enough for us, right? And then here, for our component, we just have our class, and this is our decorated component. And we can say cell equals input, boom, right? So here's our component, and now all we need to do is return our decorated component. So is not declared in any Angular module. What are you complaining about? It doesn't matter. We don't need you to be declared in an Angular module. That's weird. Anyway, now we could use this decorated component and create components that have selectors, right? Or, we could say, add debug. Right, and since our template is just a string, we can even say, hey, our we can say const template equals the template that we had, right? But we can also say inside of, well, let's do a let on this template, right? We can say, if add debug, boom, then just do template, and we can append to it, right? Yeah, and so now we've added another div that includes the pre code, right? And I need to close that. Boom. So now we've created an interesting case, right? Where we can now create a component with our own selector, right? We've set our own selector. We've got our own template, and we can modify that template. And then we return it, right? What do I have? I've got something messed up in here. Oh, there we go. Right. So now we've got this decorated component. How can we use it? Well, if we just come here and we go add components, right? And inside of here, we just say not imports. Is it? No, not imports. It is imports. Here we can say decorated components. Boom. Right. And so now we've got customized components. Well, how does this help us, right? Well, for one, we can use factories. But for two, if we get into some highly like dynamic use cases, we could make this decorated component injected with an injection token, meaning that in our dynamic cases, what decorated component does will change. So yeah, you sniped me pretty good, but you got this project to V19. A standalone flag drop was supposed to be supported. Oh, that's where my problem is, isn't it? I'm just used to that being set on its own. Here we go. Boom. Right. And so suddenly we start to get some real power. There, like stuff like this is very interesting with like unit testing, right? Because what if you just created a test component, right? And or what if we even just called this test component right here? Because now it starts to get really interesting, right? Because now you can add the selector, you can add a template, right? And now in your unit tests, you can set something like this. So, you know, app selector, right? So you override the selector, but you can provide your own test component stuff to use, right? Your own things like that. And you could potentially, you know, really go and add automatic mocking and things like that, right? And so in your unit tests, and a lot of times, like there are good libraries out there. I tend to use ng mocks, and so I just use mock component. But if you don't want to go create a library, or if you don't want to go download a library for mock component, you could very easily just turn around um, and in your unit tests, right? You've got your override, right? Um, and you've got your remove, um, and inside of here, it's an object. So you've removed imports, and here you've removed your import with steps, right, with dependencies. But then you do your add, and here you do imports, and then you can just go here and you can just say, hey, you know what? I want a test component. And we're going to say that, hey, we want app dash same selector with steps. And so it's going to match the selector here. But, then you could also add in, boom. And so now in your test bed, using a function this simple, you've taken a component that has dependencies that causes a whole bunch of unit test flakiness and all of that stuff, and replaced it with a test component that has the same dependencies, doesn't do a whole lot, but also allows you to debug it. And you could create a function this simple at a utility level, or you could create it at a component test level because maybe you want to mess with the store also, right? That's injected, or maybe you want to play with the inputs, or who knows what. But using this kind of stuff and then using injection tokens, you can do some pretty incredible things. And so, there's this kind of stuff has been fascinating to me, and it's a way to make the UX experience for developers way better in Angular. But it also allows us to reason about things easier. The biggest problem we have is that we start to look like alternate authoring formats, right? And those have been talked about a lot lately. You kind of do a bootleg version of this for Cypress and Storybook tests since it's hard and impossible. Yeah, exactly. And this is where I developed this this idea. Was working on Cypress and Storybook tests, and signals being such a problem, and having to wrap everything with a component. Well, why not make that component easier to do by creating a decorated component? Because you can create a component inline and then just return it, and it's got the component decorator. It's got all of that stuff. Yeah, the signal support is there. Yeah, and I mean, alternate formats right now are huge. But they're also a place where, there's a lot of community. The community feels very, very strongly about alternate formats. But you could very easily create an alternate format like this. Like one of the alternate formats that was floated, right, was this ng, right, and then you would have your template here, and whatever, right? Well, this is easy to do with test components because what is this called? Let's see, MDN structured string. Is that what it's called? Template literals, template strings, right? So these are template, and it's a tagged so you can add a tag function, right? And the tag function can tag a string and replace things in the string. So string interpolation, nesting templates. So tagged templates. This is the part right here, right? So you can tag your template literals. And I always forget the exact name for it. That's why I always have to Google it and remember what it is. But so like this my tag right here actually comes from this function, right? And this function takes in strings and then some different things, right? So you can tag a string and then it's going to pass these things in. So notice here that this function is taking in these two expressions, right? Person and age. And then there's strings, and you can do even more with these tagged template literals. But you could very easily just do function ng, right? And ng is going to take in strings and things like that, right? So it needs to be tagged, right? So you could take in strings, which is an array of string, right? And values any. And inside of here, you could use a decorated component, right? So this builds up this, and then you can return test component with the right template, and that's not what we want, right? Test component with a template. And so now this ng becomes an alternate authoring format, right? Now we can just say const my component equals this, right? And I've got some things that are wrong here because I haven't dug into it too much, but we've just created our own authoring format for Angular. And we did it using decorator function. So anybody who wants to get out there and, granted this is kind of the hacky way of doing it, right? The better way to do it is definitely the way that like Analog did it, where Chow and Brandon got into the compiler and extended the Angular compiler. But if you wanted to get down and dirty and author just a quick and dirty Angular, this is what I think my authoring format should look like, you could do a functional version, right? Using this and using this idea, right? So you definitely sniped me, Michael. But this is something that I've been thinking about quite a bit because at work, we're doing a lot of compositional stuff, right? Composing Angular components can be difficult. But what if it doesn't have to be, right? What if you could take Angular components and compose them down into a component that you could then inject, right? What if your components were functional and knew how to combine with each other, right? Now you could start building very, very fluent UIs using something very much based on this, right? So you guys have seen a preview into what's going on in my brain right now, and a preview into the articles that I want to write. And in those articles, I would definitely flesh this idea out more, so that it's not just theoretical, so that we actually work through it, right? Um, but I know for a fact that I've seen on Twitter something very similar to this proposed as an alternate authoring format for Angular, right? Um, and I want to be very, 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 very clear. When you see these things on Twitter, when you see them on Mastodon, when you see them on LinkedIn, these are very exploratory. Um, so be polite in your feedback. Um, Nobody's proposing any of this stuff as changes to Angular right now. What they're saying is we recognize that some of the stuff we do in Angular right now is difficult. What if we could make it easier, right? Well, what if you could make it easier for the teams that you work on by following something simple like this? Um, so, um, these are this is me mind dumping right now about what's in my notes for my article. Um, and to be honest, I'm debating reaching out to a couple of the conferences and just talking about something like this. Because I think this would be a fun thing to talk about on stage, right? We talk about, hey, this makes it easier for you to create tests, and we go through basically what we just went through right now, right? We basically go through this stuff. So you guys have seen a preview of what I'm thinking about submitting to future conferences, right? Where we talk about, hey, this makes it easier to do testing, but wait, what if we could create our own Angular syntax, right? And start talking about that. It's kind of a showstopper, um, and something that I would heavily caveat and be like, don't do this unless you really, really, really want to do it. But don't do it for any code that you want other people to maintain, because you don't want them to have to learn your syntax, right? Or something like that. If you want to do alternate syntaxes, go check out Analog. They do it well. But it's kind of a thing that makes people stop and go, whoa, wait, we can do that in Angular? So you can do some really cool stuff. And the place where I learned that this kind of stuff was possible was in the Signal Store code. Because the Signal Store does something very, very similar to this for the Signal Store. You guys, let's go take a look at the code for the Signal Store. Thought I had it up somewhere, but I don't. But that's okay. ngrx.io. Go to GitHub, and inside of here, we're going to go to modules and signals. And inside of signals, we are going to go the source, and we're going to look at the signal store.ts, right? Let's make this a little bit bigger. You guys can see it. But at the very, very bottom of this file is the actual signal store. So most of the top of this file is just setting up the types so that signal store works, which is crazy, right? Like all of this type stuff. And if you guys want to learn a lot about types, I recommend digging into the signal store stuff. I learned a lot about types just going through this code. But at the very, very bottom of this file is the actual signal store. So here's the signal store function, right? This is a signal store. These are the args that come into the signal store, and they break up the args. They, determine if the first arg is a function, then they use it for typing. Otherwise, it's a signal store feature. And then notice right here, we get an injectable right away. And if you pass in the provided in, then you get the provided in. Otherwise, you get nothing. And let's no signal and send browser for an hour. I don't care. I'm not going to be typing anything there. So um, so here's our provided in feature, right? So in your signal store, when you do the provided in the config option, it's coming right into the injectable, right? And then they create this signal store class. They set up all the features in it, add your on inits and your on destroys and all of that, and then they just return it. And this is why this, when you call the signal store stuff, you get a class that's injectable at other places. Yeah, type overloads are wicked. Yeah, you're 100% correct, right, Michael? So that's why when we come up here and this signal store, this grid store is an injectable object. Um, it's been decorated in the signal store code with the injectable decorator. There's no real, well, there is magic here. I'm not going to say there's no real magic, but there's nothing here that you couldn't do yourself, right? You're perfectly used to writing injectable, right? On your services. There's no reason you couldn't create something similar to Signal Store that would allow you to build up components functionally, right? Because that's what they're doing here. They're just using component. They're using, so when you find, you know, the on init and on destroy from hooks, well, this is where they're going, right? So when you're adding on destroy hooks to your hooks of your Signal Store, you know, your with hooks, they're broken down, they're put into this hooks object, and your on destroy hook is injected in a destroy ref, and in on destroy it's calling what you added to your hooks, right? On init is being called right after the store is created. So we've got the constructor here, right? And we're in the constructor. So they go through and they build up the signal store in a constructor. This is why you're in a construction context. And then they grab the hooks and immediately run on init, right? That's why your on init runs right after your store is created, and your on destroy runs when it does. Right? There's some more magic here going on with a whole bunch of other things, but if you look, it's actually elegant and it's not super difficult. But you could do something like this with your own services. You could do something like this with your own components that would give you some incredible powers. And so this was my inspiration for the ideas behind what I'm doing. But yeah, you sniped me good, Michael. Good job, man. That was a good snipe. You really got me off topic. But I'm happy to talk about stuff like this, right? Um, and this is the kind of stuff that I find fascinating, because we have the opportunity to really make the the developer experience, right? The DevX and Angular so much better. Um, the tools are there. We just need to think about them. Yeah, pew pew. Awesome. But yeah, that's kind of, you know, where we wanted to go with that one. I am kind of looking at my time because I want to make sure that um, I don't get too lost, right? But anyway, um, what should I do with this? Let's do this. Let's do this. Uh, let's go to GitHub. Let's add a Git. Um, and alternate, custom alternate authoring. There we go. Basis 2. alt authoring.ts. I do not want a secret gist. Let's create a public gist. Boom. So here we go. Let's for anybody who's watching along, there is the gist of the code. You know what? Let's go wild. Some alternate authoring. Here's an idea from today's stream. Boom. There we go. Whoops. That is not what I wanted to do. And let's also go take this into pretty code pictures. Carbon sounds good. No, that is not what we want. Let's go ahead and copy all of that again. Oh, I cut and pasted it. Grab the raw. And paste that into carbon. There we go. Looks fine. Let's go ahead and copy image. And let's add that to the tweet. There we go. Let's copy all of this. And we'll put it on LinkedIn also. There we go. It's on Twitter. And now we're going to add it to LinkedIn. Are you not going to let me? Why not add an image? No, I don't want. Fine. We'll do it this way. What is going on here? Come on. Oh, it doesn't like the iframe. Plain URL. Try that. Why is it so difficult to just add an image? LinkedIn, Twitter let me do it. I just pasted it. LinkedIn's like, no, dude, you can't paste images. What are you thinking, man? No, I don't want to select a file from my computer. Whatever. Can I add it in the comment? No. Why can't I just paste stuff? That's lame. Anyway, there we go. Share that. See what people have to say about it. Probably, um, probably be like, dude, you can't do that. Yeah, you're probably right. But anyway, it's out there. So if you want to take a look at it, it's on Twitter, it's on LinkedIn. Um, but I do want to say I haven't explored the idea too deeply, but it is looking very promising. Um, yeah. All right. Anyway, I'm just checking my stream stuff, and um, I'm not live. Um, I'm not following the live stuff on YouTube. I was like, oh no, YouTube, what's going on? But no, everything looks good. So we're looking good everywhere. Um, that's good. I'm just really worried after last week. Oh wow, jumping up to 7 kilobits, 7,000 kilobits per second. Never had it go that high. Hopefully it looks pretty today. Anyway, way sniped. Me on my way. I love Carbon because Carbon looks good. Um, people can take a look at it and stuff. Yeah, dude, you can't do that. I know. Um, you absolutely should call me out if you think I can't do it. But let's see if we can get this fixed up. So find cells with errors. So find cells with errors is used everywhere. So we're just using. We need to get the column to analyze. So really, we're following the idea here. So we're turning like a 9x9 grid into an array by concatenating things onto the end of it, right? We're doing that for our regions, we're doing it for our columns, we're doing it for our rows. And so if we take a look here, so check rows for errors, we're just grabbing the row out of the grid, great. And then we're doing find cells with errors. Errors analyzer is looking at each cell state. And if the error analyzer returns error, so the error analyzer returns an array of errors. For every error in that cell state, we just set the row and the column to true. So what we're doing is we're taking every row, column, and grid area, and we're turning them into an array, a flat array of 9 cells. Then our error analyzer is looking at those cells, and it's returning the cell states that have errors. That's what our error analyzer does. And so we grab each cell state that it comes back with, and we set our sparse errors array to have the row and the column with a true in it. So our array is sparse, right? So we don't have 81 elements in the array. We probably have, a ton of empty space in our array. And we did that on purpose. I remember arguing about sparse versus non-sparse arrays and discussing that. We settled on a sparse array, and it seems to work pretty well. So then, our check columns for errors, we need to find out, the column to analyze. We've got a column number, and we're grabbing that from the grid. So we're grabbing the grid, we're mapping the row and the column. Oh, interesting. This is an interesting way to do it, and it kind of forced me to think. I was going to say broke my brain. It did a little bit, but it forced me to think, right? Because what we're doing, the grid is a map of rows, right? The cells within each rows. But if we think of it really being a map of rows and then within each row, the column in that row, then what we're doing is we're iterating over every row and we're grabbing out the specific column that we asked for, right? So if we're doing column 0, then we go through rows 0 through 8 and we pull out column 0. And that gives us an array starting at row 0 of, column 0 and then row 1, column 0, and it's just this, it's a flat array. That's kind of cool. I'm proud of old me for writing this code. I like it. Celebrate where you were smart, especially for people like me who don't get that feeling very often. Anyway, I'm being a bit silly here, but so with the regions, it looks like, oops, it looks like we're going a little bit. You see this? So we set this and then we don't use it. So it takes a little bit more math to find the cells in a region, right? Because there are a certain number of columns and a certain number of rows in a region. But we need to find the starting row and the starting column. And this should probably be extracted somewhere because I know this code exists and it's even telling me that it exists. Yeah, right here, the exact same code, right? So we could do something to clean this up, and we probably will. I don't want to get too distracted. I'm already very distracted today. But anyway, we take the column. So to get the column, we take the remainder of the current region divided by the items to take, right? So we're using the modulus here. And so items to take is 3. So like if we're in region 0, we're in column 0, right? If we're in, well, and then we multiply it by items to take. Interesting. So it becomes 0, 1, 2. Does this work? It must. But say, oh yeah. Yeah, it does. And the reason it works is, let's go take a look at this, right? So this is for a region itself, but we could also look at this like our Sudoku game, right? So our regions are numbered 0, 1, 2, 3, 4, 5, 6, 7, 8, right? If we want to find the starting column for each of these, the starting column here is 0. The starting column here is 3, and the starting column here is 6, right? So 0, 3, and 6 are where we start. So here in row 0, or in region 0, 0 modulus 3 is 0, times 3 is 0, 3 modulus 3 is 0, times 3 is 0. 6 modulus 3 is 0, times 3 is 0. We get column 0 every time as our starting one, right? 1, again, 1 times 3, column 3. 4 modulus 3 is 1 times 3, column 3, right? Same here, right? It's 2's all the way down. So that works out as to where the starting column is for our region. The starting row is a little bit different. We take the region and we subtract the region modulus items to take, which again, if we take a look at what we've done here for region 0, the starting row would be 0 minus 0 modulus 3 is 0. So 0 minus 0 puts us in row 0. Here, the starting row is 3 minus 3 modulus 0 is 0, right? And then here for 1, it would be 1 minus 1. 4 minus 1 would put us in row 3. And 7 minus 1 would put us in row 6, right? So we're getting row 6 all the way across. It works the same here, right? So 2 minus 2, 5 minus 2 puts us in 3, and 6 minus 2 puts us in 6. So the math works out. So we know the column and row to start in. As long as our column index is fewer than 3, then we increase our index. Our row index equals 0, boom. And so then we just, in our region, we push on our row that we calculated up here plus our row index, right? So 0, 1, or 2. So our row is either, our row is either, if we're in region 0, our row is 0, 1, and 2, right? In region 1, it's 0, 1, and 2, right? So our row works out fine. And then our column, we push in our column index. So again, 0, 1, and 2, or 3, 4, and 5, or 5, 6, and 7. This all works out. It gets us our region cells. Oh, I'm proud of old me. That's some good code. Probably be optimized, but I like it. So we analyze it, then we update the cells. So I think this is all done. It's ready to be put into its own feature. Because it can now set the errors on the grid, which will allow us to turn the red on and off. And it also allows us to set the entire grid with errors. So let's extract this. So this one, I think we should put on the grid. And really, I think we should rename it to be. It's not going to allow me to rename this. Should we update grid has error? So now we can move this into the with grid. So into the grid feature. We've got update cell value. Stops here. So here we can also say update grid has error. And now we've got that. But that breaks our grid store. I shouldn't. Why did that break our old store is broken? So we're good moving that. So now the next thing we want to do is add a new feature. So in our store, let's go ahead and add our new feature, TypeScript file, and this will be our grid dash errors feature. Boom. And so our grid errors feature is going to follow very much like our grid feature, right? Where we just export the function as a signal store feature. So we're going to do the exact same thing. So here we can just export function with grid errors. And then we can return signal store feature. Boom. And we import that. So there we are. We've got our signal store feature. But let's go ahead and grab all of this stuff. We've got our analyze errors. We've got our update cell valid. Does update? No, it doesn't make sense because it's very dependent on this feature. So again, we're going to grab all of this stuff, including the with hooks. Boom. That's going to go into our grid error feature. So there we go. And it doesn't understand what this stuff means because it doesn't know. Well, first of all, let's go and grab these functions that aren't being used here. Boom. So those functions can all go here. So there we go. That all looks good. But we've got some problems because it doesn't understand like the state grid and things like that, right? But if we look at the pencil marks, pencil marks imports this type, right? Where we've got the grid state and then we've got some computed stuff that we rely on. So let's grab this and add that above our with methods. And I don't even think we need the computed stuff. There we go. And now it's saying, hey, if you're going to do this, it needs to be a generic. So there we go. And we're missing update grid has error, which is fine. We can fix that. That just comes up here on our type. We can say that it needs methods. And our methods are analyze errors. No. We want this one. Update grid has error. Update grid has error. Boom. And now we're good, right? So our feature is fine. So now we can go to our grid store and we can just say, hey, our grid should have with grid errors. And import that. So now we've got our signal store, our grid store, which can now handle errors. Our grid errors feature is fine. Our grid store is fine. And our old store is beginning to look pretty sparse, which is good. Because really we're getting into the where we're going to be doing the solver. But we can also do like the win state. So let's go commit this code. So we've got the grid errors feature and the grid feature, the grid store. So now we can just say, hey, we added with grid errors feature. And so now we've added one more thing, right? And we're in an interesting place because we're close, right? And where I say interesting place, I just love signal store. I love the compositional nature of it. The fact that my store is all of this code, right? This is easy to understand. Hey, I'm adding a grid to my store. I'm checking that grid for errors. I'm able to manage what's selected in the grid. I'm able to create a puzzle mode. I have undo and redo, and I have pencil marks, right? And so it's easy for me to see what's going on in my store. In the old store, right, we had to dig through to be like, wait, what does this do? This is what I love about compositional code, right? Sure, there's probably just as much code, but we've modularized it, which means we can test the grid errors on its own. We can test the grid state. Well, not the grid state. We don't need to really test the grid state on its own. It'll be tested as part of the other things, right? But we can test the grid on its own, right? And the grid is super simple, right? We can test pencil marks on its own and see, what the pencil marks should do. We can test all of this state. And part of the, the unit tests that we had here. Where are my grid store tests? Right here. So these unit tests were to write. And we didn't write a lot of them because they weren't easy to write. But we can go in and test a lot more. And the really cool thing is that because we can test more, and we can use the ideas that I was showing before, where in our tests we can provide a store that we can build on our own using functions that will build an injectable store that we can provide in the test bed. And things become really, really interesting. And that's where I want to get to, is testing. So I think we've done all of the update selected and the cell value. I think these are done. Next to focus. I think this is done. Oh, you know what? These functions I'm not worrying about. I haven't been worrying about them. It's this that I haven't. So next to focus, we've already figured out. Command stack, we still, I think this is still here for the solver. Cell value changed. I believe this is all done, but we'll validate it later. Create puzzle cell, I'm fairly certain this is all done. Reset grid. Do we have the ability in the store to reset the grid? Update cell value. Grid has errors. Update grid, but We create a new grid state. We check it for win. Oh, this is why we haven't done it. We haven't finished check for win. So we need the check for win before we can reset the grid. And this is going to have to be its own feature because it has to rely on checking a grid for win. And check grid for win has to rely on errors. Solve one cell. Unwind bad decision. These are all parts of solvers. Check grid for win. This is the one we want. Update grid 1. Check grid for errors. We can take this out. We just finished this. Yep. Update has error. We also have done that. Update cell valid. We did that. Navigate to cell. I think this one's done. Update next to focus. Update selected. No, I don't know that we've done the navigation yet. Get cell values to hide. I think, oh, these are all functions outside of the store. So the store is becoming much smaller. But I think the navigate stuff is keyboard navigation, which we'll need to add. But right now we're going to do check for win and update grid game 1. So update game 1 is pretty easy. We just go into our store. We can just go, hey, with methods, grab that, and we're going to pass in state. And one piece of state we want is to update game 1. And that works. And we can just say, hey, patch my state with is game 1. And I think it's just game 1, right? So actually, we can just change this and that. So that takes care of that method. And the reason this method looks a lot bigger is that we're using mutative, so the create method and stuff in here. But you can see that really it's just an updater that takes in the state and whether the game was won, and we just patching the state. So the last thing we can do is this code. But we want to add in our hooks here. So again, we're going to grab these hooks. And we're going to add in a hook for on init. And we're going to watch cell values change and last cell updated. Great. And then we just add in this method, right? I could probably, because I'm having to copy this over and over again. So one of the things we could do is take a look at creating a feature that could take in an RX method. But we can take a look at that later. So our RX method in the tab this in our grid store. We're going to replace that tap with this tap. And we don't even really care about the row and number, but whatever. We're not using state at all. This grid doesn't make sense. So really, all we care about is state dot underscore update game one and state dot has error and check grid completed. So let's go take a look at check grid completed. We can grab this function and I'm going to move it up here into a private function. So check grid completed no longer needs to take in a grid, but it will return a Boolean. Inside of here, we can just say, hey, const grid equals state.grid. Great. We're just checking every state. We're just checking every cell for a value. And that should be fine. And so here we can just say, hey, we want state dot underscore check grid completed. We no longer pass in the grid. And now we've got our feature for the game being won moved over. So we can get rid of check grid completed. We can leave that. Well, I already removed it, I guess. It's cell value. Oh, we're at the top. That's why I'm not seeing it. Old store, cell value changed. Create puzzle cell. Solve one cell. These are all the solvers. Check grid for win. So we've already taken care of that. So we're really down to keyboard navigation, I think, and the solver, which is good. So one thing we can do, yeah, finally, right? Like this branch, if you look, started in September 8th. So it's been going for over 2 months. Part of that has just been, I haven't been streaming during the week. But part of it is, it just takes time. So the grid feature, we can also add in the game one. Was there. Boom. So that now exists. My grid store should be happy, but it doesn't need patch state anymore. So that's what the complaint is at the top. So now we can grab our feature. Yeah. So we'll add new TypeScript file. And this is our game1.feature. And here we can export function with game1. And we will turn signal store feature. And that is what we will copy from here. We pull out all of this stuff, including the hooks. So there we go. Then our game1 feature goes right here. Now we check if our game is 1, but we also know that we need type functions. So type type. No. Is it from PNPM? Maybe it is. It is. Okay. So we need a generic on this and that. And for our state to function, we need state of grid state. Boom. And the last thing we need is we're calling a feature down here, the update game1. So we need methods. Yep, that works. And then the last thing is it wants a generic. So we'll fix that. So now we've got our game1 feature. Why is this all green? Oh, it's showing me the entire function. That's actually nice. That's really cool. It'll show me what it's returning. Well, that's cool. Or is it just showing me the return value on a function? Let's take a look here. I do with methods. I don't have a return value. I don't know. I'll need to explore that later, right? But so with game1, go here. We can import that. So now we can tell if our game has been won. And that is perfect timing. And that old store is just being torn apart. That's good. The grid store. We can say that we added our with game1 feature. Boom. And that's good. And it's good timing because I definitely need to end. Let me go ahead and push this up. But it went well today. I'm glad my internet was not a source of problems. Come here. Come here. Hi. And my friend came in to say hi. Little Indy. Hi, pup. Hi. How are you, sweet? You say hi to everybody. So, yeah, I enjoyed streaming, and yeah, Indy's letting me know it's time to finish. She's got a great internal clock, and when it's lunchtime, she's like, "Yep, you need to get up out of your office." So I'll listen to her advice and end on time today. Good time. Thank you for the comments and stuff, Michael. I enjoyed exploring some of the stuff that's been on my mind, and we will explore it more when we get into the unit testing. So that's why I really want to get through this stuff, is I want to get into the unit testing stuff, and I'm hoping to get this stuff done soon so we can start getting into the actual xState, which is the title of this stream, and we haven't done a single xState thing. So I'm looking forward to getting into xState and then exploring some more ideas that I've got for that article. And then, yeah, we'll be back on Tuesday. Tuesday should be fine. So snipe me from xState. That'll be awesome. I love talking about state machines. I think state machines are an often forgotten feature about coding, but they have the opportunity to turn your code into something that's so much easier to reason about when done properly. Let's put it that way, right? So I definitely am looking forward to that. But we'll see you guys all on Tuesday. You guys have a great rest of your weekend.